So thank you very much for coming to this talk this morning about the AI-powered discovery tool, otherwise known as Project Fleming. A bit of a disclaimer before we begin. This following presentation is not an official Shell document. It is what follows therein is the opinions, the history, the experience of developers working on Project Fleming, and it is not intended to be an official opinion of or a statement on behalf of Shell. We do have definitions and cautionary note. And we do have definitions and cautionary note, but I won't go through that in detail, but that gives you a further disclaimer. So let's do an overview. So basically, discovery is often an accidental process. So hopefully all of you can see the picture of Alexander Fleming right now. Please tell me if you can't. Okay, silence is golden. Penicillin came about because Alexander Fleming kept his lab in an untidy state. He went off on holiday. He went on holiday to Suffolk, I think, and then he returned from holiday to find that on his messy desk that mold had grown in his petri dishes. And then he found out that the mold that had killed the bacteria that was in the petri dish. And so he was able to uncover the first antibiotic. And it's one of the great challenges in innovation in science. How do we encourage more such happy accidents because we are so reliant on them? Don't believe me? Here's another example. Charles Goodyear is the guy who invented vulcanized rubber. You know how tires are a very hard black rubber that in order to make contact with the road. That wasn't always the case. Goodyear had worked since 1834 to find a method to stabilize rubber. That is, to prevent it reverting into a soft and pliable material. He tried treating it with various chemicals. He tried various processes. Most of his attempts failed. However, accidentally, he found a way to harden rubber because he mixed it with sulfur and then he had it on a hot stove. And increasing the heat made it harden. He patented the process in 1844. Without that, most of modern transportation as we know it, everything from bicycles to cars to everything else, would just not have been possible. So what does this mean for InnerSource? Well, put very simply, having a repository set to open just isn't enough. It just doesn't cut it. Organizations often have thousands of repositories. Shell, every other organization that I've worked for, major organization I've worked for, has thousands. And we also have a tendency to work in geographic or functional silos. So you are basically, you may have one GitHub estate. However, because of the geographic or functional silo, the repositories that you're working on is actually just quite a small segment. And current search tools operate on the principle of specificity. You know what you're looking for. Is that true, however? Is that really always true? If you recall penicillin, vulcanized rubber, the role of serendipity, the role of accidents is really important. So how do we increase the area by which these happy accidents, this discovery can take place? And how do you effectively enable InnerSource if it's impossible, not just to find what wants, but what didn't know what wanted? How can we enable finding the unexpected? And so this is where Project Fleming comes in. So I will talk about the beginning of it. And, I quote one of my favorite books, The Beginning is a Delicate Time from Dune. My first InnerSource job, and talking a little bit about myself, I was working with a major global bank. And the initial hurdle within the bank was getting the default set on repository set to open. When you create a new repository, the default set to open. However, the question arose, what do we do after that? Because with thousands of repositories, how do you curate? How do you promote? How do you push forward repositories that are of high value? How do you assess that something is of high value? We were presented at that point with Backstage.io, and I understand that's quite popular with the InnerSource Commons, and that is, in my opinion, part of the solution. However, the thousands of the repositories that were involved made that solution seem too limited. If you had like, you reach a certain point where you become blind to the amount of repositories that you're seeing, and you're, oh, hang on, something's going on. Oh, okay. Sorry, I was just seeing something in chat. And so if we open up our estate, how would anybody find anything useful? and that was a particular problem. And then, of course, while I was there, the artificial intelligence revolution landed. And so while I was at the bank, we started having the idea that you could use AI to leverage, you could use that to get happy accidents. At the same time, for my sins, I was working on a second PhD in engineering at Loughborough University. And what I was trying to do was specifically track innovative behaviors in online community. And I read a paper written in 2017 by a data scientist named Casper Christensen, who was working out of a Norwegian university, and he had found a way using Python and R to identify ideas and non-ideas within an online community using machine learning. And this his test case was doing it for the Lego community. I used Google Vertex AI to try and do the same thing for a electronics engineering community with a fairly ambiguous set of rules, and it was able to do so with 77% accuracy. So, given this, why not use AI to enhance the discovery process? Because AI can operate with ambiguous rules, and then it can look beyond and have it so that it looks beyond standard search for related information, things that you didn't necessarily expect, but the machine can see the pattern. So, at stage one, here at Shell, my team and Ben, and I see Amber in the audience, have developed an AI powered discovery tool. And we leveraged AI by looking at the README files associated with repositories. And this provided a much expanded process of discovery. Furthermore, we were able to use models that were downloaded from Hugging Face. So everything is open source. And necessity was the mother of invention. We last year, and I'm not telling any secrets, is that Shell committed to some substantial cost cutting, and our budgets were impacted by that as everybody else was. But because of these constrained costs, the team was made to think in a creative way. How do we do this? How do we develop this? With a team focused model. So, for example, we relied on a community of volunteers in order to do this. We didn't always have a cost code for people to use. How do we do this in such a way so that it runs economically? So, the team found a way of using it to build it using a CPU rather than GPU clusters. And the other thing that it also forced us to think about is how do we carry the project forward? Because, quite frankly, Shell isn't a software company. And the project Fleming is a more generic use case. And so one of our goals at Shell is to push out software that has a more generic use case into the open source world. We did this with our sensor gathering platform, RTDIP, which gathers data from all of our sensors across the estate and organize it for purposes like digital twins and so on. And discovery seems to be a common issue in the inner source community. Hence, we pushed this out to open source in November 2024. We're looking for more contributors. We have a number of different things that we hope that people will be able to use it for. And the other thing is that even within Shell, we are finding that it's not just for indexing, curating, or indexing code or information that is necessarily to do with code. We use it to look over other information resources as well. So how does it work? Well, data from any internal data source can be ingested. Our first iteration uses GitHub, but it's customizable to your own needs. From this, a corpus is constructed for every entry in the database, and an embedding is generated for each one. These are then passed into the LLM, and using a pre-trained sentence transformer model, vector embeddings are generated for each entry and stored. The model is then configured so that it can be queried. The results are ranked with cosine similarity between the provided query embedding and the underlying document embeddings. Using a threshold for the cosine similarity score, the model can be customized to filter only highly relevant results. So what do we get out of this? Well, the result is a highly efficient engine which uses a CPU rather than a GPU cluster. This means that the infrastructure costs for the shell-wide application are in the hundreds rather than thousands of dollars. And this is for the entire Shell developer community. And because CPU clusters are less energy intensive, we're more environmentally friendly. And this also has the side benefit of enforcing inner source quality standards. We are adhering more or less to the patterns that we see in the inner source commons, where we have a maturity model. We've developed this in collaboration with our working group, which includes parties, includes developers and managers alike. And the maturity model helps us to make code shareable, also ensures security, but also it means that the discovery tool means that if you haven't put in, for example, a good readme, we can't find you. If you haven't put security, adequate security on there, then there will be an absence of a badge on the results that you get. And so we also are seeing increasing emphasis on reuse metrics as a metric for success. So the Fleming also does something else now. We have further metadata enrichments using AI. So Fleming also helps you construct virtual readmes. So which can be ingested into the model to help improve searchability or of specific code functionality. So Fleming makes the core code functionality searchable through the code summary class, which integrates with Azure OpenAI to generate the code summaries with the prompt shown, currently using ChatGPT 4o Mini. Often a README included in a root directory of repository will give a high-level overview of the project and its purpose, but this won't always detail the specific code functionality, as this would be too granular. However, when a developer is going to search for reusable code, they will be looking for specific functionality or topic areas. So the prompt that we're using is, the following code is the contents of a repository. Generate a short summary paragraph describing what the repository purpose is. A paragraph detailing the key functionalities and technologies. Integrate with and a list of keywords associated with the repository underneath. Focus on the purpose of the code contained in the repository and the technologies, data, and platforms it integrates with. Lists up to 12 keywords associated with the project. The total output should be no longer than 400 words. And we have been testing it recently to ensure that the results that we're getting back are the results that people want. And the results have been very promising to begin with. But we also have this as part of Project Fleming, which is in the code summarization module, which Ben released in January. So having said all that, I will hand over to Ben to do a demonstration. So let me just stop sharing.
Thanks, Christian. And let me just share screen myself. If you guys could please confirm when you can see it. Can you guys see that okay? Great. Okay,
Yep.
Firstly, just want to quickly introduce myself, guys. Hello, good morning, good afternoon, or whatever time of day it is if you're watching us on YouTube. My name is Ben Butcher. I've been working at Shell with the Inner Source Enablement team and Christian for just over 2 and a bit years now, working as a technical business analyst / junior developer, kind of doing a bit of everything. It's been a real privilege working with the Inner Source team because I often describe what we do as working as a startup. So I've got the opportunity to try quite a few different things here. So looking forward to demoing Fleming and how it works today. We've got a demo for you. And if I just firstly just check that people know where to find Fleming. So if you haven't already, please visit the MKDocs website. So this is projectfleming.tech. And then also the repo can be found in Shell's open source domain, SETI Open, and that's where you'll find the repo. So next slide. And I'll do a quick walk through the code. So something we've tried to do with Fleming is make it as simple as possible. So what you see on screen right now is all the code that you need to get Fleming up and running. It's really that lightweight and simple. And for this, actually, I will now jump into Databricks just to make it a bit easier to digest. And there's 3 main imports that we're going to cover in this demo. So there's corpus text creation, model train register, and model serve. So the first task that we do here in getting Fleming up and running is reading in our data. So for this demo, we're using a Databricks SQL connection to pull data from a Delta table that we have in the Databricks workspace. However, you could use any internal data source, whether that be a CSV or another form of table. You can customize it to your needs. The only thing that you need to get back from the end of it is a data frame that we read in. And so for this demo that I'm going to be showing today, we're going to be showing how Fleming can be used on Shell's open source GitHub estate. So we'll be looking at repository information. So you can see here we have repo name, the link to the repo, the languages content of these repositories, what type of license file it has, and a README summary. So this README summary for this demo, we've taken the text README content and generated a short summary just for this demo using the Google T5 open source Python package, which summarizes text. And that's slightly different to the AI stuff that Christian was just talking about, but I'll go into that in more detail a bit later down the line. So you can see we read in the data here, and then we create the corpus from this. And so we specify the path to the corpus, and then what we're doing is concatenating these columns, these ones that you see here, and then we're into a format which we can then pass into the model and generate the corpus vector embeddings as a result. So we then move on to the train and register the model. So it's configuring the model, getting it set up for use in the Databricks model registry. At this point, we're not actually doing any training, and particularly in this demo, we're just using a pre-trained model. So you can see here, we specify the BERT base cosine similarity model that we've got from Hugging Face. We specify the model directory, the corpus file location, corpus embedding file as well. And then we register the model to the Databricks model registry. And then once that is done, you can then serve the model to the Databricks serving endpoints. You can see here we use a CPU and a small workload size. And so for context, that comes to roughly per endpoint, 1 to 200 euros maximum. So really quite low. And it enables us to actually have multiple endpoints running for different internal data sources. So what you see at the top here, you'll see that for this example, we're only looking at repositories. However, Fleming could be pointed to look at internal forums such as Stack Overflow, internal best practices and guidelines, or whatever you want, really. That's we've designed it to be as open as possible. So if I then go back to the slides, I will show you. So I wish that we had a live front end to demo for you guys today, but this is something that we're actually looking for contribution for to get a demo live endpoint up and running. But for today, I can show you some of the queries that we have in the Databricks serving endpoint, and I've also mocked up a front end for what this will look like for you guys. So just to give you guys a sense of what the front end would look like and what our internal front end looks like, I've mocked up this PowerPoint presentation here, this slide. So hopefully this is going through. There we go. So welcome to Project Fleming demo front end. And the way that we've structured this is you'll see you pass in your query here. There's a series of filters that you can apply. So code languages, code maturity, whether that be with if you want to have different code scanning modules or services in place, such as SonarQube or MEN, for example, or GitHub Advanced Security, you can add these in as filters. You can also add whichever filters you like, dependent on the data that you pass in. And then you can see here, we have the results coming down here where these tags are coming up. And you'll see, crucially, the important thing to note here is you see 4 different tabs here. So each of these different tabs represent a different serving endpoint using different data. So in this example, we have GitHub here. So we've got the repository links, and that's the data that I've showed in the code earlier, and I'm going to show in the backend shortly. But then there's also internal forums that you could click on here. And so what that looks like for us at Shell at the moment, we've got, for example, the internal Stack Overflow. And so you can see you can pull in different questions, articles, that sort of thing, and also display if you have an accepted answer or not. And so the idea behind this being that we want a developer to be able to use Fleming for any sort of knowledge reuse or discovery. And sometimes you're going to go there and you're not thinking, I know exactly what type of project I'm looking for or the code. I'm more just maybe interested about a particular topic area. So we want the developer to be able to find all the relevant information. So whether that be a related project, an internal forum, developer guidelines as provided by the organization that you're working in, or any internal data source. You know, we've experimented potentially with SharePoint and other sites. So it's really open and can be tailored to your individual use case. And then, so this is the front end. And then what I'd like you to imagine, come with me on a journey, is that you can then see these, we're going to be passing these queries in. And so this, I'm about to show you guys jumping into the back end, what this looks like. So we've got a few different example queries here. So if I just zoom in a bit further, you can see, for example, AI discovery tool. And tell you what, let me just jump into the example endpoint instead. So this is what the back end of the endpoint looks like. And so when we send the request, you'll see that then we're returned with a list of dictionaries and we get, or predictions as it were. And these are the search results. So we've just searched for AI discovery. And thankfully, Fleming is the first one to come up in the shell open source estate. And if I then take you back to or you'll notice something in this response here, and let me zoom in a little bit. You see you have the repo name, the repo link, the languages used in the repo, the license file, and you can see these is delimited here currently with spaces, and then we have the README summary. And then we have a relevancy threshold there as well. That's the relevancy score that is returned by the model. And so using this, we then pass this into the front end, and there's a bit of additional code that then, say, for example, looks at, right, well, I'm going to display this section that would go here. And then you have this section. So, for example, the languages tags, you could then get your front end to look for that, and that then appears in this section here of your results. And so we have a few other queries we can do. Say, for example, serving using CPU models. And then let's have a look. There's actually some different results here. So this could be interesting if we're looking for other projects that are serving using CPU models. So we have here something that's AZ Fluid Reactor Modeling, one of the open source repos. You can see the different languages present here. If we scroll through, there's other repos available here. And then if we, for example, were to search for, what was the other query we had here? Let me have a look. Let me find it just here. Databricks server models running on CPU. There we go. Let's see. Here we go. So you can see other projects here working in Databricks. If you're interested on, seeing some other projects to get some inspiration, and you'll see that Fleming again pops up here. And so if I then move on here, Christian also mentioned so that's the querying of the model, and that's worked to a certain degree. We found that worked, and that was our first iteration of the tool, just using a short summary or some of the original README content of the repository. However, if you wanted to search for specific code functionality rather than project domain context, we thought, well, why don't we start taking the underlying source code, concatenating it together, and then passing it to the LLM, to a different LLM, to generate a summary, which would then detail the functionality, which would make that more searchable, because we then pass that summary into the model, we index it on that, and that's led to a big improvement in performance. So what you're seeing on screen here currently is the code summary generated for the Project Fleming repo. So you'll see here, the repository named Fleming serves as the foundational infrastructure for an AI discovery tool specifically designed to facilitate the extraction, processing, and analysis of data from GitHub repositories. It integrates various functionalities for data ingestion, model training, serving, and querying, leveraging Databricks as a primary platform for big data processing and machine learning model management. The key components include a GitHub data processor that retrieves and concatenates repository files into a structured format, a model training module that trains semantic search models, and a model serving endpoint allowing users to query these models efficiently. Additionally, the repository utilizes Azure OpenAI's API for code summarization, enhancing the documentation and understanding of the process code bases. Key functionalities encompass data extraction from GitHub repositories, data cleaning and tokenization for model training, semantic search capabilities through pre-trained models, model serving via Databricks for real-time querying, model summarization using Azure OpenAI's language models, and the repository is built using technologies Python, PySpark, MLflow, and sentence transformers, and it's designed to work seamlessly with cloud-based services like Databricks. And then you can see some of the keywords it's generated there. So all the content that we passed in here was the underlying source, the scripts, so the classes imports that we saw earlier in the presentation, and the README file. And you can see that just on one generation, we're using 4M Mini that is, costs a couple of pennies. It's done a very good job of going down into the actual depths of what the code does on a very descriptive level. So if you were searching, for example, say for, data extraction from GitHub repositories to create, I don't know, inner source metrics, whatever it may be, we found that it's led to a real boost in performance. And we've also found that the Project Fleming code summary has some additional uses that we weren't initially aware of. So we've been working with some compliance teams internally at Shell to use this as a way of identifying uses of different techniques, libraries, packages, and it's a useful safety rail for ensuring enterprise-wide compliance, because often teams want to, they have to volunteer information. This is a good way of sometimes checking, what else is in our estate. It's also helped us highlight a number of empty and duplicated repositories across the GitHub organization. So when ingesting the data, we calculate total token counts, and sometimes these are exactly the same, or the summaries that we generated were very similar as well. So this has helped us highlight things that we needed to then actually focus on for cleanup. And we also found that this prompt, it can be tailored to suit your needs. So focusing on data platforms and technologies, for example, or focusing more on the code purpose, or in particular, generation of additional metadata tags and keywords. And additionally, the GitHub extraction and tokenization package can be tailored to look at or ignore specific file extensions or file names. And this gives you a lot more control over what is included in the generated summaries to suit your use case. And so this is something we've experimented with, for example, including and not including the README file. And the reason for this variation is that we found sometimes the additional business context is a good way of grounding the LLM when it's performing a summary of the code, and other times it's not helpful. So this is something that you may want to play around with and let us know how you get on with it. And crucially, we found that the main use of the code, as I said, is it enhances the search for direct code functionality instead of needing to look through multiple projects and digest the business context in the root level README before getting to the code. And there's further applications beyond code summarization that we are really excited with the prospect of people getting their hands on Fleming and letting us know how they get on with it. So I think I can pass over to Christian and the rest of the crowd first for the Q&A. But before I do that, just wanted to give a massive shout out to our team member, Amber Lindsay-Rigg, who is in the call today, was unable to join us for the presentation, but just wanted to really showcase the level of work she's put into this is, second to none, and we wouldn't be here without her. So a big thank you to her for all her contributions. And with that, I can pass over to questions.
And the other thing is that I would like to thank Ben as well, who I'm 52 years old and I haven't contributed to an open source project before in my life. This is the first open source project that I've pushed out to, but Ben and Amber now have who are substantially younger than me, have that wonderful experience, and I have to credit them with coming up with such novel approaches to the problem, and in particular the breakthroughs such as moving from not needing a GPU cluster but a CPU cluster. So what they've made is truly groundbreaking in terms of its capabilities, its use case, and the lightweight nature of the application. So we can move now to Q&A, Anna, if you want to. We can just do that now.